Hello, programming languages students. Welcome to our first C video. And in our first C video, we're going to be working with Java. This is the only time well, maybe the very last time in the class we'll even really dive into Java at all, is when we talk about how Java and C manage memory. Um, and so hopefully by the end of this, you'll see that there are some behaviors in Java that you may not have expected unless you truly know Java. There's going to be some strange outputs here that maybe you don't expect. And I'll talk about why C gives us advantages when it comes to problems like the ones we're going to walk through here. So to start in Java, okay, we create an int x, which is 3, int y, which is 4. We call a swap method with x and y. So the swap method, which by the way, it's the same at the bottom of my method. They're declared at the bottom of my method here. But in order to fit more on the screen, I've copied them into this extra file on the right for quick reference. Um, so This is the swap method. Takes two integers, stores the first in a temporary variable, then assigns the first to the second, then assigns the second to the temporary variable, effectively swapping their values. Um, so we take x equals 3, y equals 4, we swap them, and then we print out x and y value. So take a second, predict what the output you expect is here, and then we'll run it. All right, so what did we get? X value is 3, y value is 4. Wait a second, we called the swap method. Why didn't they swap? So if you predicted 3 and 4, good work. If you predicted 4 and 3, the reason for it is that in Java, when you call a method, we pass by value. What does that mean? Well, when we swap x and y, we're not actually passing the variable x and the variable y in. We're actually passing the value stored in x and the value stored in y. So we're really swapping the value 3 and the value 4. Now, the way it works though is A gets assigned to 3, B gets assigned to 4, we swap them, and at the end of this method, A and B have been swapped, but X and Y have not. So when we go back into main, X and Y, nothing happened to them. We just took their values and swapped their values in the method, but the variables themselves and the values that they're pointing to are totally different. This is a scope issue. X and Y are in main, A and B are in this method, and the value is the only thing that's passed, not the actual variable, the spot in memory. You have to think about this. X and Y are a spot in memory that store values 3 and 4. A and B are totally different spots in memory, and we just copy the values in, swap the values there in this totally different area of memory, and then try to print X and Y. Well, X and Y aren't affected. They are not in the memory that was swapped. So so that's a basic key Java principle. It passes by value. So let's look at our next example here. We create an array with a value 0 and a value 1. So index 0 is 0, index 1 is 1. We call swap2 with the array 0 and 1. For the moment, I'm going to comment this line out. We'll jump back to it in a second. And then we print array at 0 and array at 1. Well, the swap here works the same way. We take the array, we take indexes, we get the array at the first index, store it in a temp variable, array at first index equals array at second, and array at second index equals temp variable. So effectively swap the values. So what should we get? Well, take a second, predict, and array 1, 0. Wait, the swap method works now? How does that matter? Well, here's the trick. Java always passes by value. That's the very first rule. But the value it passes may not work the way you expect it to. When we call swap with ARR, ARR is an array. If we actually were to print ARR, what value is actually stored in it? What is the value stored here? Well, it gives us this string of kind of gibberish, but it's not really. What it really is a specific address in memory that ARR points to, or that ARR is stored in. So this is an object. An array is an object in Java. And so objects frequently have their values stored in Java as addresses. So when we actually call this int array points to the value passed in by ARR. Well, the value passed in is a memory address. And so when we change things with this array, and actually in here, square brackets, this is actually called dereferencing. We'll talk a lot more about it with C. But we're getting a specific spot in memory as an offset from the spot in memory where array starts. So array at 0 is the value at the spot in memory pointed to by array. Array at 1 would be the value stored in memory at the location, the memory address stored by A, plus the size of one integer to the right of it, or down from it, depending on how you visualize, but one element over. So we're actually truly accessing the memory pointed to by the array up here. And so when we swap values down here, we're actually swapping the values in the memory address, this memory address, pointed to by the original array. And so when we dereference the array here and get its values, they've changed. This is all about memory and how memory management happens. And so in this case, our memory management happens by passing memory addresses and changing memory addresses. So arrays in Java all reference memory addresses, and so you can actually swap values from an array in a method. So let's do one more example here. We're going to create a double object. Note the capital D double, not lowercase d, for A, which is going to be a new double with a value of 3.0. B is 4.0. We're going to swap using the same methodology so far, the two double objects, and then print them. So predict what the output will be. Will it be 3.0, 4.0? The swap didn't work, or the swap does work and we get 4.0, 3.0. Or you just have no idea at this point because who knows what the heck Java's doing behind the scenes. Well, we get 3.0, 4.0. So the swap doesn't work. We have a double object, we have a double object, we swap them, we print them, and they didn't swap in here. Why? Well, turns out some of the classes, some objects that you create, don't use memory addresses. Some do, arrays, some don't. In this case, double is treated more like a primitive double, lowercase d double. And so memory addresses aren't involved, and so we're copying by value and we're not actually changing the double. So Java's a little bit unpredictable at times in terms of how it manages objects and how it manages memory and addresses, and that affects how your code runs. And so if you're not sure about how memory is working and how the details of Java memory management happens, who knows how the program's going to work? So let's do our last example here. This doesn't even use methods. This is just an interesting point in Java. If you played close attention in CS2, you'll know what happens here. But if you didn't, this will be a good refresher. So we make a point. You can look up the point class if you'd like to. We make a point. It basically stores x value and y value. You can set new x and y locations. You can get x and y values. So it's a point in space, right? So we have a first point, 1020. We have a second point at 3040. We change the first point's location to 100, 200. Change the second point's location to 200, 300. We set second equal to first, and then we set the first location to 300, 400. So for the first printout, what do you expect to happen? There's a couple different paths here. Take a second, if you want to pause the video, pause it, and predict what the printout will be. After you've predicted that printout, we're going to do second.setLocation, 400, 500, and then we're going to print out first and second again. So again, predict what will happen here. Feel free to pause the video and make your predictions. What will be the two sets of printouts here? Well, here we go. What we get, first printout, both first and second are 300, 400, and in the second set of printouts, both first and second are 400, 500. Well, if you got it right, congratulations. You understand how objects and pointers and variables work. If not, here's a really quick tutorial. When you create our new point here, this is an object. This object stores the values 10 and 20, and the variable first is basically pointing to the memory address where these values are stored. Then second points to the memory address where these values are stored. So we have two objects, two variables, both pointing to their own objects. So these methods work. We change first to 100, 200, second to 200, 300. The tricky line is here in line 28. When we set second equal to first, what this is actually doing, this is not just copying the location from first into second. Second does not become 100, 200 as its own, like this object does not change so that its values are 100, 200. Instead, what happens is the variable second now points to the same object, the same memory location pointed to by first. So this object. What that means is there is now no variable pointing to this object. The object we created and were originally pointing second to, this is space and memory, storing numbers, storing values, is now no longer referenceable. Second is now pointing to the same object that first points to. So we have two variables pointing to one spot in memory. And again, this is because objects are stored often in Java based on memory location. So this assignment is actually telling us that we're going to assign the variable second to point to the object in first. And so now they both point to the same object. So when you change first or you change second, both of them will change. So hopefully that makes sense. The last thing I want to mention is that in C, a lot of these details are, there's default behavior in C that mirrors this a little bit. But in C, it gives you control. You can control exactly how you want to reference or pass values into methods. It can control how you want to treat objects. Do you want to use their memory address? Do you want to use their contents? And so C is all about getting control over the fine nitty-gritty details. Java doesn't actually let you do some of the dereferencing and referencing and memory management that C does. It kind of hides it in the background. And so C allows you more control, which allows you more precision and more guaranteed outputs when you call a method. You will know what's going to happen. You don't have to understand the really deep details on how objects are stored or treated or how arrays are stored or treated as you go through. So C will help us manage this a lot better. See you next time.